And we are live with Interchain Live. This is Ryan Munn in Vermont. Thank you for joining us today. We have ULedger, and we've got Pete Anwalt and Josh McIver on, the co-founders of ULedger today. I'm really excited to hear about how they're implementing blockchain and have already done it in some really interesting use cases. So thank you guys for joining us today.
Thank you. Our pleasure. Thanks, Ryan.
Yeah. So Pete, let's start with you. You're the CEO and co-founder of ULedger, right?
I'm the COO. Actually, Josh here is our CEO.
I always get all those letters mixed up.
Yeah, no worries.
They don't even matter.
Right on. Yeah, I like CVO. Have you guys caught that? Chief Value Officer?
What is it?
Chief Value Officer.
I like it. I like it.
Yeah. So right on. So thank you guys for joining us today. Pete, why don't you start it off? Give us a little bit of your background and kind of what brought you to where you are today with ULedger.
Yeah, sure. Happy to. So my background is, many years in software and technology, my whole career, kind of as a developer, as a consultant, as a project manager, executive manager. And I kind of like small companies. Small companies do interesting things, and they move fast, and they break things, and it's a lot of fun. And, a couple of years ago, I got wind of this company here in town, we're based in Boise, Idaho, that was working on blockchain for enterprise purposes. And I, knew of blockchain at a really high level from a cryptocurrency standpoint, and I had never really thought of its use outside of that sphere. So got to talking to these guys and, got a sense for what they were looking to do and found it really interesting. And I've heard it described as kind of falling down the rabbit hole, and that's what happened to me. So, really got into the details of blockchain, how it's been built for cryptocurrencies and how we would need to build it differently to support what we envision to be valuable enterprise use cases. So
Right.
been digging into it ever since, and really enjoying working with the team here. Josh here's our CEO. Our CTO is a guy named Talent Ramaboya, who is a very brilliant developer. He's kind of been in the blockchain space since it was a thing. He lives in Europe, and we're really glad to have him on the team.
Awesome.
And we toss it over to Josh here for his bit.
Yeah, Josh. So did you suck this guy into the rabbit hole?
I did. Yeah, I did my best to. It was interesting how we came about, Pete, but he's been a game changer for the company. My background, and I'll be brief. I started my career at Deloitte in their Denver office in their audit practice.
Okay.
And it was my experience there that ultimately led to us creating ULedger, because when you go in and you do an audit, you look at a company's books and their GL and their processes and their systems, and at the end of the audit you write a somewhat subjective opinion as to the accuracy of their financial statements and their the trustworthiness of them as a company. So fast forward a few years, I worked for an oil and gas company. I got my MBA, worked in a private equity firm for a few years. But I was working for a startup in Utah that was looking to create a reputation economy platform. It's the idea that your reputation follows you wherever you go on the internet. And people can rely on that reputation for anything from loans to the comments you lead you write in a comment section. So anyways, to do that, you need something like blockchain technology so that reputation score of yours is trustworthy and trackable and all that. But when I learned about blockchain, I immediately kind of went back to my audit days. Blockchain inherently is a trustless, third-party, immutable record of something. And so I was thinking, wouldn't it be amazing if an enterprise had this base layer blockchain technology where they could have an immutable record of data and use that to prove to a third party, such as an auditor or regulator or even customers in the public. They can say, okay, you're using this technology. Now we can believe that you're not out there manipulating your data. And if you are manipulating your data, there's a trail of that. And so that was the premise of ULedger. And as Pete's going to go into, we looked at we didn't want to have to create an entirely new platform. It's a huge undertaking, right?
Right.
And we looked at Ethereum, we looked at Hyperledger, and at the end of the day, we decided these, while they have their place in the blockchain space, they aren't suitable, they aren't the best option in an enterprise. And so we took on the enormous task of building an enterprise blockchain platform that is quite a bit different than the other ones out there. And people go into that soon.
Awesome. Awesome. Yeah. And, I'm really excited to hear, I've obviously looked at this quite a bit, talking with you, Pete. You guys, in fact, Pete, we had you on quite a number of months ago on the channel here. And full disclosure, by the way, you guys and I have a little bit of business going on. So typically my videos are purely pre-business, but we've got a little bit of business going on with this RFI in Vermont. And I think I'm hoping that this is going to be a great resource for them to get a good understanding of what ULedger can do, what blockchain can do, and how we can start opening doors to the future with these technologies. So
yep, that's great.
That's awesome. So Pete, I'm curious, real quick, what was it that really clicked with you guys as a team? Like, what made it happen where you guys have come together and really made this thing happen? Because you guys have done some really great projects, and I'll let you guys get into that maybe after we do the presentation. But what made this team gel?
Well, I think a couple things. We have very complementary skill sets between the three of us co-founders. That's important. I mean, there's a good and clear sort of division of responsibility, and we each bring different skills and background to the mix. And then there's the business problem to be solved, which we all think is enormous. It's an enormous problem, and there is enormous potential for the technology to be applied to the problem. So, that as a small company, that's a lot of fun if you've really sort of carved out a big and difficult problem, right? And you have a plan to attack it and bring a solution to bear that, frankly, we feel like the world needs. That keeps you coming in every day. And as a startup, we never have any money. We never have, we're never sure. The money's always going out. It's hard for it to come in.
Right.
You never know what each day is going to bring, but that's the kind of thing that keeps you going, keeps you coming in every day, is that we think we're solving a real and very important problem.
Yeah, that's awesome.
Yeah.
It's incredible when you find that mission at hand. So let's take a look at ULedger.
Sure.
Let's get started off here. I've got your most recent presentation deck up here. Not too long, but a good amount of information here. I was browsing through it earlier, and you guys have definitely done a really good job of getting the key points forward, I think. So take us through this. Where do we start?
Well, let's move forward one, and we'll start there.
All right. Who is ULedger?
So basically, we've kind of gone over this. There's a lot of builds here, Ryan. Just build the whole slide out, and we'll kind of chat.
Is it okay? I got it. All right.
Like we talked about, we're focused on a very specific problem, business problem. We're leveraging blockchain technology to do it, and the results are applicable to what we call the enterprise. Really, by that we mean corporations, small businesses, large businesses, governments. Basically, anybody who deals with data that's got value, and that's everybody, right? So our focus is on leveraging blockchain to create a provable, immutable history for critical enterprise data. We are headquartered, like we mentioned, here in Boise, Idaho. Our CTO, and we have a development staff in Europe as well. Just finished building this out, and this is us guys that we've already talked about.
Yep.
Yeah,
awesome.
So that's who we are.
And so what are we solving?
Yeah, like we mentioned, it's all about what we call data integrity. So in other words, the technology is able to provide integrity, certainty, and proof to corporate data. Blockchain does that. It creates an immutable, tamper-proof history of data. And that's got value. Most of the data infrastructure that we deal with today in the corporate world, it's database-based. And there's a lot of data. We collect a lot of data. We manage it. We delete it. We archive it. We transfer it between organizations and all that. Yep. And there's databases that do that. And the databases are good at doing that, but what they're not good at is proving the content of data over time. They're really unable to tell you whether somebody has changed a particular record, when they did it, you know, whether what you think is in there is really what it was when you put it there, and there's really no way to know that. And why does this matter? Well, the whole notion of data integrity, like Josh mentioned, audit is a good example, because mostly in today's world, you have to enlist a third party to come in and vouch for your data. That's auditors, that's lawyers, that's, you know, consultants and people like this. And it costs a lot of money. And so, you know, the notion of spending money on auditors to come in and issue an opinion on how reliable your data is a problem, and it's an expensive problem. And blockchain can do a lot to reduce the costs associated with that problem. If you have the ability to create and present a provable and mathematically coherent history of data, you are that much further along in the audit process, or if you get sued, or if you need to demonstrate regulatory, you know, your adherence to government regulations and things like that. So that's the focus. That's the business level focus of what we do.
All right. All
We
right.
have a number of customers, as you can see here, that have you know, used this technology and found valuable use cases. I should mention that all of these are really very different use cases, because this notion of data integrity can span verticals and can span a wide variety of use cases. So, you know,
Yeah, you know what, let's pause there for a second. Let's talk a little bit about some of these use cases. You know, I know the one that springs to mind because it's really easy to explain, I think, and it was something that you guys just recently mentioned to me, and that's the email service where you're creating the audit trail essentially for the email application. Break that down for us a little bit.
You bet. So think about it as an email archive, which many companies need anyway, and there's many regulations that require email archives to be maintained, but this is one that's blockchain backed, and so therefore what you're getting is an email archive where the content is provable, it's independently corroborated, it's legally discoverable, and it is very simple and straightforward to set up with ULedger's architecture, right? This is a really good example of one of those use cases where a traditional, let's call it traditional blockchain, if there's such a thing as tradition in this, you know, young industry, but a traditional blockchain like Ethereum, for example, is public, is not very scalable, and is not the sort of solution that you could leverage to create an immutable history of your email. But email is a really good example of corporate data that is important and it has value, and creating an immutable history of it is a valuable thing. And just one example of the type of data, and with our solution, it's really any kind of data that you could treat in this manner.
So I want to kind of break down some separation here too between cryptography, which we've used for many years, right? And when, say, evidence comes into the you know, evidence locker, they take information from the compiled history and they add the new information and they hash it, and that's one of the ways that they verify that chain of custody, right? So that's not totally new, but there's some key components to what you guys are implementing that really enhances the reliability of that, because even in that instance, it sounds great, but if somebody understands that cryptography and they can go in there and wipe the history and create a new history when they change something, then nobody knows the difference. The next person that goes in sees a clean slate and it looks fine, and they think everything's good, but somebody's been able to tamper with it. So where is it that changes, or, you know, how are we taking that base concept and enhancing that to provide what you're creating?
Yeah, so what you just talked about, that's kind of the notion of a private blockchain, right? There is such a thing as a private blockchain that's got all the cryptography and all the stuff that is sort of part and parcel of blockchain, but it's private, meaning a particular organization runs it in-house and they don't share anything with anybody. So what you get is very good data security, where you don't have data security with a solution like Ethereum. But what you sacrifice in doing that is immutability. You have no independent third-party validation of what you're doing and what that content is. And so without that, you can do exactly like you just said. Somebody can go in and rewrite your history of data. So what we've had to architect is, it's best described as a hybrid solution. It allows you to keep data private, yet still acquire independent corroboration of each transaction in that private data store.
Yeah.
By means of a cryptographic hash. So any data going into a data store is hashed, and that hash is corroborated by other independent nodes on the network. So what you get is basically a private data store that you have access to and keys to and can control who sees that. But while while data is being added to that private data store, the network is taking care of anonymizing and getting that independent third-party corroboration so that you wind up with an immutable audit trail of data that nobody else has actually ever been able to see.
Got it. So we know that nobody will have tampered with those emails. Whatever's in there is in there. Nothing will have been able to have been changed without there being some kind of an indication that that change was or that data was corrupted.
Exactly right.
So let's just throw out another use case. You said you had some very different ones. So what would be sort of something on a whole nother spectrum that you guys have got the opportunity to work on?
Yeah, okay. So one use case that we like to talk about quite a lot, and there's an insurance company that we're working with on this right now, is cybersecurity oriented. And it was an interesting response to the question, if you have if you have the capability to create a highly scalable, private yet independently corroborated, immutable history of data, what use could you put that to? And one response that came back was, well, hackers, when they hack into a network environment, they often delete traces of their presence from system logs. So they go into server logs, basically, that track who logged in and what they did, and they remove data from them. They remove the lines that indicate that they just logged in and they did something. And so,
right.
If we, could your solution allow us to create an immutable copy of our system logs in real time that we could use to compare against the real system logs and see if anybody is modifying that data?
Gotcha.
Really interesting use case, and one that you could never, accommodate with say a public chain like Ethereum. The data volumes are much too high. The value of the data, until you discover that somebody has changed it and hacked in and changed it, then the value is very high. But the value of most of that data, is relatively low, and so a traditional solution just couldn't handle it. But we're working with that insurance company right now on this exact use case, underpinning system logs with blockchain, and then doing a real-time comparison between the two to detect any occurrences where there's a mismatch.
Got it. Now, how does the implementations of your solution actually, as much as you're saying Ethereum doesn't necessarily apply very well to these solutions, it still has its place. Bitcoin's doing its thing. There's all these different platforms that are building up, doing all kinds of different things. There's bound to be some useful stuff that comes out of different sides of the market. Now, how does this kind of open the doors to really interoperability and integration?
Yeah, really good question. So, the notion of a single chain or a single solution that will sort of dominate the universe is probably a non-starter, right? So interoperability has to be where the world starts. And from our standpoint, we've taken the architectural design tenet that says, a single chain doesn't make sense. A single chain that the world is going to use, it's not practical, it's not scalable, it just doesn't work. There's no need for it. What corporations need, what businesses need, and what governments need are multiple data stores for different purposes. And each of those comes with its own history of data. And so those data sources then work together to collaborate and certify each other's data. So any given customer, any given ULedger customer, be that a corporation or a government or whatever, they may have multiple blockchains. One for email, one for their cybersecurity initiative, one for their documents that they deal with on a daily basis, one for financial transactions. It doesn't matter what the data is. The point is that each of those data stores is doing something different, has a data history that it needs to maintain. The world doesn't care about any one company's emails, and so there's no need for a single universal chain that attempts to hold all that stuff. But by getting those nodes to work together and collaboratively certify any data that's going into any one of those data structures, that's how you get immutability. And so then, when you have your private and trusted and independently corroborated data store, well, you can do with that whatever you need to. That's, typically we're looking at that as, a lot of our customers are looking at that as, well, I need to, that's my input into the partners that I deal with.
Right. And to be clear, you guys aren't really, or are you even trying to address the like decentralized processing or application operating code? I mean, you guys are really on a sort of a protocol level of data validation or authenticity.
Yeah, that's exactly right.
So like Ethereum, for instance, they may, somebody wants to build something that's going to run on a decentralized blockchain. They're still going to, look to some platform like Ethereum that runs code. But if they want to interact with and sort of, maybe pay their taxes per se, and a government's got this system set up, all it takes is for those coders working in Ethereum to understand the protocol and how to interact with what you guys have built. And now we're all on a level where there's transparency on both sides.
Yep, that's exactly right.
Awesome, awesome. Well, here, let me get you fired back up here.
I have to run too. Sorry to pop out in the middle of your thing, but it was good talking to you, and talk to you soon.
Yeah, Josh, great. Thanks for joining us. I really appreciate you being here with us.
You bet.
Awesome, Pete. So here's we're back to the presentation here. So let's jump ahead. I know we could probably dig into another half a dozen use cases for you guys, right?
Yeah, we sure could.
Yeah.
Tell you what, can you advance to the next slide after this?
Yeah.
Because it starts to get to some of the meat and potatoes stuff that. Whoops, sorry, these should have been hidden. So
no worries. This is a little bit of history.
Everybody knows Bitcoin by now, right? So
yeah, for the most part.
Right. This one too, and then let's hit the next one.
All right. There we go.
So this is an important one, right? What do enterprises really need from a blockchain-based solution? In our view, they need 5 things. Those things down the left-hand side there. There are data privacy. No enterprise, no company, no government wants to share data with the rest of the world. However, they don't want to share data, but they still want immutability of that data. So to get immutability, you need independent third-party corroboration, yet you don't want to share the data. So like we talked about earlier, that's a conundrum. Right. Our solution addresses that by being a hybrid. It creates multiple independent data stores that are private, but those private data stores work together to collaboratively certify data, any transaction placed on them. And so by that means you get both data privacy and you get immutability. Next is scalability, right? One of the big problems with public chains is their lack of scalability. And this is by design mostly because of the use case that they were built to support, which is cryptocurrency typically. Right. And you want to prevent the double spend problem with cryptocurrency, and you need mining as a solution to ensuring that the same coin can't be spent twice, and you utilize mining to make sure that you have enough nodes in the network that all have to agree on a single chain, but all that's very slow. And the notion of all the companies in the world leveraging one chain, like I mentioned, you can quickly see how that kind of tends to fall down.
Right.
So scalability just isn't there. Hyperledger or other private chains are better, but they still, they still share that same architecture, single chain, multiple nodes, as you can see there in the upper left of this diagram.
Yep.
And that's an inherently limiting architecture. Ours is different. There's many chains in the mix. There's many nodes in the mix. Each node, all those nodes work together on a peer-to-peer basis to certify each other's traffic, which is what makes us highly scalable. And then another key thing is simplicity, right? Blockchain can be fiendishly complicated, and enterprises need a simple solution that doesn't require them to replace all that existing data infrastructure that they've spent billions on. So we accomplish that by means of a very simple API layer on top of our product that allows each blockchain to be treated as a database that data is read to and can be, written to and can be read back from, but obviously once data is in there, it can never be deleted nor changed. And so we think about that and describe that as an overlay to an existing infrastructure, right? You can add what one of our customers has termed an accountability layer to your existing data infrastructure.
Right. So there's a key point there too, is you mentioned a minute ago how the public blockchains oftentimes are using this proof of work mechanism where they use a lot of processing to validate and protect that chain. Now,
Right.
instead of making all of that effort to validate and protect the chain, my understanding here is that you're basically relying on reputation, where if someone is violating the chain in some way, the key here being not that they're prevented, but that they are essentially red flagged at some point in their
Well,
corroboration.
not exactly. So let me
Okay,
let me
good.
describe. I think the truth is somewhere is in there somewhere, but let me make
Okay,
sure to clarify. We do not have a concept of mining like public chain like traditional chains, both public and private, do.
right.
The process of mining is one of enlisting nodes to become part of the network and
Hmm.
incenting those nodes to perform the work that's necessary to validate transactions. And so it's necessary in a Bitcoin and in an Ethereum model, right? Because
Hmm.
you want to have a lot of nodes, but they are all volunteers, and you have to incent them to be part of that somehow, so they get awarded some currency when they solve the problem. Our architecture is, like we mentioned, it's fundamentally different. There's many nodes. They work together to certify each other's data. It's not reputation based so much as it is everybody's in the network for the same reason. They all want their data certified by others, so they're willing to perform those certifications for others. And so that's what keeps the network working. There's no need to incent any one particular node because a node tends to be there because it's got a database attached to it that it wants certified and it wants its immutable audit trail of as well. So the work happens between nodes, because there is I'll give because I'm going to get
Right.
interplay.
Now then, is there a permission component to who can operate a node? I mean, is there ultimately ULedger Central deciding who has the right to get a key that's valid on the network?
Yep. So good question. And there's a difference between what happens today and what we want to have happen, right? And we're still hard at work developing our solution. And what we want is to put this in the hands of corporations and businesses, any of whom can spin up a ULedger node within their own environments according to whatever needs they have for that, right?
Mm.
And then what will happen though is the network, like we mentioned, it's a hybrid. From a network standpoint, you do not need permission to join the network, and you don't need permission to seek certifications from others and provide certifications to others. That's the layer above the the layer above works that way. Then the layer below is private, right? So your data and your private data store is permissioned. You hold the keys to that, and you can provide access to that to no one if you want, or whoever
Right.
you deem needs that access. So that works in two ways. Again, we're a hybrid from the
Yep.
permission to permissionless model standpoint.
Gotcha. Excellent. So, enterprises use ULedger. Now, we mentioned email already, and we mentioned
Yep.
the security audit trails.
Yep.
Walk us through a couple of these other use cases you guys are
Sure.
working with.
So the common thread of all of these is data integrity. There is important corporate data that needs to be proven in some way. Email is a good example. Another really good example that we have some customers doing is around due diligence documentation. So let's say, for example, property title is an example of that. Asset securitization is an example of that, right? I've done this work to certify this body of data that's moving on to the next partner downstream, and I want to use the blockchain, a
Right.
blockchain-based data store to create a provable record of having done that. there's some really good examples in the public sector here of data that, anytime data is involved in um, handling by public entities, there's a desire for transparency.
Hmm.
There's a desire to ensure that people know that their data is being handled properly and with appropriate safeguards and in a transparent and provable manner. So, we're really starting to get some good traction between government use cases as well. And then there's a whole other category of data that's on the right-hand side here, which is
Yep.
maybe data that doesn't necessarily belong to you as a company or a government, right? But it's data that you deal with. It belongs to others, and you want to create an audit trail that verifies your proper handling of it. Really good examples of that are medical records that are subject to HIPAA privacy
Hmm.
requirements and GDPR in the European Union, where you have to take actions on customer data based on customer requests. So, again, maybe the blockchain is not the right place to store customer data because obviously you can't delete it from there. But when a
Right.
customer does ask you to delete their data, you really do want to store in a blockchain-based place the fact that you took action on that. You received the request, you took action on it, here's the proof, and I'm demonstrating my compliance.
Right, right. That's very interesting. Now, where does this meet the end user or consumer? So, if we're talking about personal data,
Mhm.
one of the things that I've been exploring and working with people in Vermont, anyways, around is the fiduciary responsibilities around data,
Mhm.
and so getting companies to basically account for how they monetize our data, as
Mhm.
well as data security in terms of putting the data, the sort of the golden nugget, behind a firewall of individual security. So if a hacker per se wanted to hack some data, they'd have to individually hack each end unit as opposed to
Mhm.
going to one repository held by the hospital and being able to get all 700 million records or whatever they've got
Yeah.
stored up.
Yeah. Um, Really good question. There again, the notion of decentralization, and which is really kind of part and parcel of blockchain in the first place, is
Hmm.
super important there, right? So there's no central. What you need is an environment where there's no central authority of trust, right? No central entity that keeps all the data, no
Hmm.
central entity that has to be, trusted to provide permissions to do things. And so that's really the promise of blockchain overall is that those permissions and those capabilities become distributed. Um, how that extends to the individual level, I'm not sure that I have a clear view on that at the moment. The technology is still relatively complex, and it's probably, in the short term anyway, going to need for individual use to have an application in front of it that helps them manage that.
Right,
Um,
right,
but once that's in place, then the data that they have access to and that could be stored in structures like this is exactly that type of data that people are most concerned about right now, um, in regards to people's reputation and what they tend to do on a daily basis and websites that they visit and products that they purchase and all that kind of stuff.
yep, yep.
So there's an awful lot of potential where blockchain is going to be able to be used as a solution to those things.
Right. Excellent. Excellent. Yeah. And I think that, we have a big opportunity to use these technologies to uh, take back our control of data as well as get our value out of it. I think there's a lot
Right.
of value being created, but a lot of people aren't necessarily seeing that value hands on, and this can show it to us.
That's right.
So you mentioned earlier the covering the hacker's tracks, or preventing the hacker covering his tracks
Yep.
using our security audit system, and
Yep.
that pretty much covers it, right? Did I? Yeah, with that.
No.
All right.
Yep. That's the material. So that's
Awesome.
hopefully a good sort of business oriented sense for why this is important, why the technology is important. Um, how we ULedger anyway have taken a different approach than we feel most other blockchains have in terms of realizing a way to actually use that technology productively today.
Right. Awesome. And I just want to also point out to folks that you can go right to the ULedger website. It's uledger.co and get a few more details and descriptions. You've got some video up here explaining things, and a really nice website. Yeah, so any last pontifications you want to drop on us as far as your kind of vision for where ULedger can help us take the future?
Well, yeah, so I mentioned earlier that a single solution for the needs of the universe probably isn't realistic, and yet that's kind of what we're trying to build. Whether we really do conquer the universe or not, I don't know, but I kind of, my sense is that blockchain is fundamentally a very important technology, and we've only really scratched the surface of it. We do see the technology being ubiquitously applied in the future. At a very foundational level. It's just too important for the underlying foundation of our data management, environment that we live in today and that we're going to be dealing with going forward. Blockchain can do important things. It takes trust out of the equation. That's immensely important, right? Today we're still required to trust entities that frankly may not be deserving of our trust, right? And you can look in the news headlines for examples of that. Equifax is a great example of that.
Oh yeah.
Wells Fargo is a great example of that. There's many. Anderson Consulting was a great example of that, right? Maybe one of the best ones. So these are organizations that we have to place trust in, and it may not always be the right thing. This technology allows for trustlessness, the need to not have to trust any particular entity, and the world really needs that. And we kind of think that it's going to go from where we are today, which is early adopters. Think about it like the web was in the 90s or so. And websites, well, that's kind of interesting, but I don't quite get how we'll use it, until it became mainstream. And finally, it became, if you don't have a digital presence, you're really not a serious business. And we kind of think the same thing is true of blockchain. Early adopters are saying, okay, I get it, and I'm in. The mainstream is going to say, well, okay, if they're in, then maybe they're getting an advantage out of it, and I'm going to jump in too. And finally, it's going to be, if you're not doing it, why not? Are you trying to hide something? Are you, do you want to be able to delete those emails and all that kind of stuff? And so, we think the adoption curve is going to go something like that, and we're still relatively early days in it. So, it's going to be an exciting ride, no doubt about it. So we're all in, and we're just anxious to see how it goes and do our part to take it where we can.
Awesome. Yeah. Well, and I can't agree more. I mean, I think that establishing data authenticity is a huge step in the right direction. That unfortunately, there's lots of pockets of the world that don't feel that pain, or are separated from it enough to not necessarily feel the need. But most of the world feels that need, and it's just a matter of getting the right stakeholders on board and getting things moving forward. I mean, and the reality is that, all these tokens that are out there, they could all be tracked on any blockchain. And as long as we're building things that are interoperable, there's a whole lot of opportunity to innovate and collaborate and create real lasting solutions. So I'm excited to see what we can do with ULedger. Exactly.
Well, we want to be right in there with everyone else, and we really do feel that our solution is groundbreaking in a number of really important ways, and can do its part to solve those problems. So we're anxious to jump in.
Awesome. Well, thank you so much for joining us today, Pete. I really appreciate you sharing ULedger with us, and keep up the hard work.
Will do. Well, thanks again, Ryan, for the opportunity. Really appreciate it, and pleasure to chat with you today as well.
Awesome. And to the audience, thank you guys for joining us. Thank you for paying attention, joining the conversation, and I look forward to talking with you again soon. Have a wonderful day.